I'll be doing graphing functions and their intervals with intercepts. It's describing the x and y intercepts of the graph of a function and identifying increasing and decreasing intervals. It'll be SOL A11.7. Now, I always like to think of functions as a roller coaster because just like a roller coaster, they'll be moving up and down on a graph and crossing over itself at various points, like at the axis or the grounds in a roller coaster. Essential concepts first are the x and y intercepts. Those are points at which the graph of a function will cross an axis. I always remember it as if the point has a 0, intercepts your hero. If a point has any x but a 0 in the y place, then it is an x-intercept because it will be crossing over the x-axis. If it has a 0 for the x but any y, it will be a y-intercept because it's crossing over the y-axis. Now, an increasing or decreasing interval is a portion of the graph of the function where the line will slope in either a negative or positive direction only. So it'll be an interval between 2 points where the function is only moving in one direction. A turning point is the point on the graph where an interval begins to increase or decrease in value from where it was going before, so it'll become either positive or negative. Now an example, what statement describes the graph of gx, x plus 2 divided by x squared? So this graph crosses over at the x-axis at -2, 0, but it does not cross the positive side of the x-axis nor the y-axis. Therefore, the graph has one x-intercept and no y-intercept. So we can see here that around -2 on the x-axis, it'll cross over and become negative, and there is your x-intercept. However, on the other side, there does not cross the x-axis. So there's only one x-intercept, and this function does not ever cross the y-axis as you go up. So it has no y-intercept. So just one x-intercept and no y-intercepts. Second example. Now, if we take another graph and we want to know what intervals it is only increasing in, this graph will be the f of x of 3 minus x squared minus 2. The intervals of this graph are going to begin -infinity and move to positive infinity. We'll be really reading it left to right. In order to find the end of the interval, we need to find the turning point on the graph. So since the function begins to increase in the y value at 3, -2, 3 is the turning point on the x-axis, and turning points are very, very important for intervals, so you should always be writing down your turning points on the x-axis. So the function is decreasing through the interval in -infinity, less than x, less than 3, and decreasing throughout 3 is larger than x is larger than positive infinity. See here that the function begins from -infinity and is moving steadily downward until it reaches 3, -4, at which point it starts moving back upwards again. So we can say the interval is from -infinity to 3, and then from 3 to positive infinity. Now an application problem. Let's say you're making a wooden frame in art class for a painting. The area of your frame, just to make sure it's nice and structurally sound, should be around 28 square centimeters. The inside of the frame should measure 11 centimeters by 6 centimeters to match the painting, because obviously you don't want to put the frame on top of the painting. So in order to find this, we want to know how wide should the wood be in order to measure up to what the area should be. So the formula for area in this will be 11 plus 2x times 6 plus 2x centimeters squared. We cross multiply this out and we get 4x squared plus 34x plus 66. Now we want to cut out the middle of the graph, which is 11 times 6 centimeters, and we'll end up with 4x squared plus 34x. Now, the area of the frame should be 28. So on the graph, we're going to be looking for 28y as the value. And the area of 28 is a line across parallel to the x-axis, so it should equal 28 square centimeters when x is about -9.3 or 0.8, where it intercepts the graph. And since you can't have a negative value of an area, the area has to be 0.8 centimeters.